The lab number 4, using statistics to analyze experimental data, is going to involve a lot of calculations. And at this point, you have gone through and you have completed the pre-lab, and as you're watching this video, you may or may not have completed the lab experiment itself. However, there are some things that I felt were important to point out to you. So as we look at the front cover, this is where we have the purpose and the background information to get you started. As we delve further into the lab, I'd like to point out to you that there are a series of example problems that are going to help us as we proceed with doing the work on our own. So I'd like to point out to you that at the bottom portion of page 62 of your lab, this is where we find information on the mean or the average, and we have equation number 1 that we're going to use for that. As we go over to page 63, this is where we will find the equation for error, equation number 2, deviation, equation number 3, and you may have noticed that I had already highlighted in purple and I have some highlights in blue pointing out the importance of average error and average deviation, okay, which are right here. Okay, and then of course equation number 4 that's included. This page right here is very, very important because as we look at this, we want to keep in mind that we define average error as the sum of the absolute values of the errors calculated for all the measurements divided by the number of measurements. Similarly, we define the average deviation as the sum of the absolute values of the deviations divided by the number. This last sentence right here, the smaller the average error, the more accurate the measurements, the smaller the average deviation, the more precise the measurements. So that's a really, really critical piece of information. Additionally, as we slide down page 63, I'd like you to notice that Dr. Paterno has made an addition to her lab in that she had a typo. Okay, so right here, given a reasonably large set of measurements, about 95% of the measurements should fall within 2 standard deviations of the mean. So please make sure that you correct that on your lab. Okay, the next example that I want to point out to you, because this is really important, is on page 64. Okay, so as I zoom out, you'll be able to see that I went through and highlighted things in different colors to make my life easier as I was preparing to teach this. This example problem is exactly what you're going to do after you have collected your data or if you've already collected it. Okay, so you're going to notice that this example uses the length of a car key, and it goes through and it gives you your series of measurements. Okay, so we have 5 different measurements with lengths that are all measured in centimeters. So please notice that you're using equation 1 to calculate the mean. Okay, so just quick reference back. Equation 1 is right over here. All right, so we go through, we take the numbers, we calculate the mean. Okay, from there, you're going to look at what's called the median. Okay, so out of the values that you've recorded, the median is the one that is the middle one, the 5.52 value. Okay, now that as they're going through, then goes on to have you calculate the error. So as you're doing the error, you need to make sure that you determine that your error value is the value that you recorded measured and subtracted from what's considered to be the standard value. So I've highlighted that for you right here, which is the 5.51. So that's a given. And you subtract each of them. So like that's what's being done right here to get your error. And you're going to notice that some of them are positive and some of them are negative, and you want to make sure that you account for that as you're recording them. From there, you take the average of them. Okay. Then from the average error, the next thing we want to do is the deviation. The deviation is your measured value minus your mean. And you'll notice that these values are coming from up above. Okay, so your measured value is 5.52. Your mean value actually was what you calculated above, the 5.53. Okay, so 5.52 is this first one, minus my mean of 5.53 gives me that first value. Then you take your second value, subtract your mean, your third value, subtract your mean, etc. And then as we continue on and we end up on page 65, this is where we're going to calculate the average deviation. So the deviation values that you just obtained, okay, which were again at the bottom of this page, here are our deviations. Okay, then you get the average of them. Okay, now once you have your average, then you will find that calculating the standard deviation on page 65 is explained to you. And as you go through and you plug all of your numbers in, you do your math on it. Okay, so that's all right here. All right, what does that tell us? It goes back to the fact that we expect 95% of all of the deviations, measurements of the car key made using the ruler to be within 0.02 centimeters of the mean, which is 5.53. In other words, we would predict that if another person measured the length of this key with the ruler, they would most likely obtain a measurement between 5.51 and 5.53. Okay, now you're going to do that with your data. Okay, so again, if you've completed the lab, then you've already gone through the procedure. And you will notice that on each of these data sheets that you have values recorded, there are additional calculations that you have to make on each of them. You need to show work for everything. I can't stress that enough, because literally over half of the points for this entire lab experiment are for showing work. Please feel free to do it on separate, clean, either lined or regular paper. Your good copy should be in blue or black traditional ink. Okay, so you're going to do that on that data sheet. Okay, here's your result sheet for the beaker and for the marbles. Show all of your work there. And finally, for the test tube and the boiling water measurements of the thermometers, show all of your work here. Again, I can't stress it enough. Show all of your work on separate paper so that it's easy to follow and easy to grade, because every single calculation is worth points. Okay. Then you get to the interpretation of your results, which are start on page 73. And you will notice that on this particular page, question 2 has been crossed out. As you go to page 74, there are additional questions that you also need to answer, which are worth points. Okay, now what you're seeing on page 76 is an example problem that was on the back of your pre-lab, and you did not have to do it as part of the pre-lab, but it is a great practice to be able to make sure that you're doing your calculations correctly for your lab. Okay, so as you're looking at page 76, I'm going to again just scroll back to where I was when I was going through pages 64 and 65. You are mimicking what you're seeing here. Okay, so this example problem, page 64, continuing on to page 65 is what you have to do when you are finishing the lab. And I would challenge you to do this as a practice problem to make sure that you understand how to do it, because the goal is to understand the data, understand how to apply this going forward, because this will apply to things that you're going to see in the future in this chemistry course throughout the entire year. Okay, so at this point, I would always encourage any questions that you may have. I also would really appreciate it if you would sign up to follow me on my YouTube page and on my Facebook page, so that all of the likes that I get are always very helpful to me, and hopefully you're finding that what I'm providing to you is helpful. Okay, so thank you again. I challenge you to do this problem, and if you wait a couple of minutes, or not even a couple of minutes, but if you just wait, I'm going to slide to the end of my presentation for a little bonus. Thanks so much. Okay, and again, I appreciate your assistance with my social media. Thank you.